Implement inter-VLAN routing. This topology. Addressing table. Required resources on real lab, 2 routers 4221. On Pocket Racer, I'm using 4321. 2 switches 3650. 4 PCs, console cables, Ethernet cables. Build the network, ready. Cable network, ready. Configure basic settings. All these basic settings for the devices. Copy this to a notepad. Okay. Router R1, review configurations. Okay, and copy this to R1. R1. No enable configure terminal paste. Okay. R3. Copy. Okay, this should be R3. Command line interface. No enable configure terminal paste. Okay, very good. V1. Shut down all interfaces. But on Pocket Racer, you can use the following. Remove this. Interface range. Shut down. Okay, this will work on Pocket Racer. Copy. D1. On physical tab, place the power supply. Okay. Command line interface. Enter. No enable configure terminal paste. Enter and review. Okay, very good. And very good. Okay. Switch D2. Interface range. Shut down. Copy this on D2. Okay, at the power supply. Okay, this power supply and command line. Enter. No enable configure terminal paste. Review. Very good. Very good. Configure and verify Inter-VLAN routing on layer 3 switch. D1 will act as a layer 3 switch and D2 will act as a layer 2 switch. You will configure and verify Inter-VLAN routing on layer 3 switch. The default switch database manager SDM template on Catalyst 3650 running iOS XE supports dual stacked operations and requires no additional configuration for our purposes. Okay, this is valid for real app. If you are using alternate device running Cisco iOS, check the SDM template with show SDM prefer and verify the number of IPv6 unicast routes supported is not 0. If it is 0, you must change the SDM template to one that supports IPv6 using the SDM preferred template name on global configuration mode. The template name will vary depending on the iOS version. Changing the template will require reboot. Okay, this is valid for real app. D1. Enable routing for IPv4, for IPv6. Create two VLANs, VLAN 50 and VLAN 60. D1. Exit IP routing, IPv6 unicast routing. Okay. VLAN 50, name group 50. Okay, case sensitive for this. VLAN 60, group name group 60, exit. Okay, assign gigabit 23 to VLAN 50 and 24 to VLAN 60. Okay, 23 to VLAN 50 and 24 for VLAN 60. Interface gigabit 1, 0, 23. Okay, interface. Switch port mode access VLAN 50 no shutdown exit and 24 mode access VLAN 60 no shutdown exit. Create the switched virtual interfaces SVI that will support VLAN 50 and 60. Okay, on layer 3 switch D1, configure the switch virtual interfaces. Okay, interface VLAN 50, IPv4 address 10.2.51 24, IPv6 address, link local FE80, colon, D1, column 2, link local, IPv6 address 2001, DB8, ACAD 1050, D1, prefix 64, 001, DB8, ACAD 1050. Okay, D1 64, no shutdown, and VLAN 60, interface VLAN 60, 10.2.60.1, 24, link local FE80 D1 3, IPv6 address 2001 DB8 ACAD 1060 D1, no shutdown, exit. Configure PC1 with the addresses specified in the addressing table. Further assign default gateways of 10.2.51 and 1050 D1. Okay, PC1. The default gateway for IPv4 10.2.51 and for IPv6 2001 DBA ACAD 1050 column D1. The addressing table use this IP 5050 10 to 5050 24 50. Okay, and IPv6 address use this. Okay, 50 prefix 64. Okay, now configure PC2. Okay, this configuration 10 to 60 50 24 for subnet mask and IPv6 address 106050 prefix 64. And for PC2, default gateway 10 to 61 and IPv6 default gateway 1060 D1 column D1. From PC1 ping PC2's IPv4 and IPv6 address. Success indicates that D1 is performing inter-VLAN routing. PC1 ping IP address of PC2. Okay, ping 10 to 60 50. Success. Okay, and ping to 2001 DB8 ACAD 106050. Success. Examine the MAC address table on D1. Okay, go to D1. Show MAC address table dynamic and show MAC address dash table dynamic. Enter. Okay, Packet Tracer will not support dynamic, but you can use only show MAC address table. And you can see two entries, okay, just like this. One for VLAN 50 and another for VLAN 60. You should see PC1 and PC2's MAC addresses listed with the ports they are connected to. Okay, go to PC1, ipconfig/all, and look at this MAC address 0090/0C934496, and is connected to PC. PC is connected to port 23, and port 23 use VLAN 50 0090/0C934496. Very good. And the same way with PC2. ipconfig/all 00604740 5DA7 00604740 5DA7. Very good. port 24. On D1, configure routed port and default route towards R1. Okay, this link and configure this interface gigabit 1011 with routed port. Okay, configure terminal interface. Configure terminal interface gigabit 10/11. Okay, no switch port and IP address 10.113.13.255.255.255.0. IPv6 address f80 : D1 1 link local IPv6 address 2001 DB8 ACAD 10 D1 : D1 prefix 64. Okay, 2001 DB8 ACAD 10 D1 : D1 prefix 64. Now shut down. Okay, exit. Verify gigabit 1011 is no longer associated with VLAN database by issuing the command show VLAN brief and pipe include gigabit 1011. There should be no output. Okay, and show VLAN brief pipe include gigabit 1011. Enter. Okay, Packet Tracer will not support this output. Packet Tracer will not support the pipe with include. Okay, use I include. Okay, will not support pipe with include, but you can use only show VLAN brief. Show VLAN brief and gigabit 0 and gigabit 1011 is not here. Okay, no gigabit 1011 because it's not longer switch port. Configure a static default route for IPv4 and IPv6 that point towards interface address at R1. Okay, the next hop is this one for IPv4 and : 1 for IPv6. And on D1, configure the routes. Configure terminal IP route, the default route. Next hop IP address 10.1.13.1. IPv6 route :/0. The next hop IP address 2001 DB8 ACAD 10 D1 : 1. Okay, enter. You may see the error message adjacent resolve request failed to resolve. This indicates that the switch sent an ARP for MAC address of 10.1.15.1 and got no reply. Okay, and don't worry about this. This is for real app. On R1, configure interface addressing. Okay, now configure R1. Okay, enable IPv6 unicast routing, configure gigabit 001 and serial 011. Gigabit on this side and serial on this another side. IPv6 unicast routing interface gigabit 001 IP address 10.1.15.1 IPv6 address FE80::1 link local IPv6 address 2001 DB8 ACAD 10D1 colon 1 prefix 64. Okay, now shutdown, exit, and interface serial 010, interface serial 011. Okay, sorry, is serial 011. The IPv4 address 10.1.31.24. Link local FE80 colon 1 colon 2. Link local IPv6 2001 DB8 ACAD 1013 colon 1. Now shut down, exit. Okay, very good. Configure routing on R1. Configure static routes to the network supported by D1 and default route for everything else pointing at R3. Okay, two static routes for the VLANs here on D1 and default route to reach another networks on R3. Okay, the first IP route, this is the summary for VLAN 50 and VLAN 60. Okay, IP route 10.2.0.0.285.285.0.0. The next hop 10.1.13.13. Okay, for R1, this is the next hop 13. Okay, enter. And two static routes for IPv6. Okay, for VLAN 50 and another. Okay, on R1, IPv6 route 2001 DB8 ACAD 1050 colon prefix 64. Next hop IP is 2001 DB8 ACAD 10D1 colon D1. Okay. Okay, D1 next hop for R1 to reach these VLANs. Enter. And for the VLAN 60, 1060, same next hop IP. Default static route, IP route for IP4 quad 0 and next hop 10133. Next hop is this for 10133, and for IPv6 the IPv6 route colon /0, the default route 2001 DB ACAD 1013 colon 3. Okay, very good. From R1 ping PC2 with IPv4 and IPv6. Okay, ping PC2, these are the IP addresses, IPv4 and IPv6. Go to R1 and ping 10.2.60.50. Okay, 10.2 success. And ping IPv6 2001 DB8 ACAD 1060 colon 50. Okay, this is column. Success. Configure and verify a router-based Inter-VLAN routing. The default switch database manager SDM template on Catalyst 3650 running iOS XE supports dual stacked operations and requires no additional configuration for our purposes. Okay, this is the same warning that will be applied on real lab, okay, on real laboratory. Configure D2 to support the required VLANs. And remember, D2 is a layer 2 switch, and create these VLANs. And go to D2, exit, VLAN 75, name group 75, and VLAN 85, group 85, VLAN 999, name native VLAN. Exit. Assign 23 to VLAN 75 and 24 to VLAN 85. Okay, 23 to VLAN 75 and 24 to VLAN 85. Okay, interface gigabit 1 0 23. Switch port mode access. Switch port access. VLAN 75. Okay, not shut down because previously all ports were shut down. Not shut down. And 24 mode access VLAN 85. Not shut down. We create a switched virtual interface that will operate within VLAN 75. Okay, on D2 interface VLAN 75, IP address 10.3.75.14.25.25.25.0, IPv6 address FE80 D2 1 link local. Okay, IPv6 address the global unicast 2001 DB8 ACAD 3075 D2 prefix 64 001 DB8 ACAD 3075 D2 prefix 64. Now shut down, exit. Create IEEE AO2.1q based trunk on R3. Okay, R3 will make the inter-VLAN routing. Okay, R3 the router, and as a part of the configuration of the trunk, set the native VLAN to VLAN 999 and filter the VLANs allowed on the trunk. Okay, configure all this on D2 and on interface gigabit 1011. Interface gigabit 1011. Switch port mode trunk. Okay, but before to apply the trunk, switch port trunk and encapsulation .1q. Okay, because it's AO2.1q. And now switch port mode trunk, and then switch port trunk native VLAN 999 and switch port trunk IOT VLAN 75, 85 and 999. Enter. Not shut down. Okay, because ports were shut down previously. Okay, exit. Okay, 75, 85 and then native 999. And now configure R3 to support inter-VLAN routing. Okay, configure R3 to support IPv6 unicast routing. Okay, on global configuration mode on R3. IPv6 unicast dash routing. Okay, configure sub interfaces needed on R3 gigabit 001 to support the configured VLANs. Interface is created for the native VLAN 999. Okay, enable the physical interface gigabit 001, this interface gigabit 001, but I will do it at the end. Let's start with this, the sub interface gigabit 001.75 encapsulation.1q75. Okay, is encapsulation. Okay, the IP address 10.375.1.25.25.25.0. IPv6 address fe80::3:2 link local. IPv6 address 2001 db8 ACAD 3075::1 prefix 64. 2001 db8 ACAD 3075::1 prefix 64. No shutdown. Okay. The interface sub interface 85 encapsulation 85 IP address 10.3.85.1 link local fe80::33 IPv6 unicast 2001 db8 ACAD 3085::1 no shutdown. Okay, and interface sub interface gigabit 001.999 encapsulation .1q 999 with this native VLAN. Remember that, no shutdown. Go to physical interface gigabit 001 and no shutdown. Very good. Configure PC3 with the address specified in addressing table. PC3. The default gateway is 10.375.1, 10.375.1. The IPv6 2001 db ACAD 3075.1, 2001 db8 ACAD column 3085::1 is 73075::1. Okay, go to addressing table, configure this for IPv4 and IPv6. Then 37550 prefix 24 255.255.0 IPv6 address 2001 db8 ACAD 307550 prefix 64. Okay, very good. Okay, is this PC4, these IP addresses 10.385.50 prefix 24. The far gateway IPv6 address 2001 db8 ACAD 30885 : 50 prefix 64, and default gateway 10385.1, 10385.1, 3085 : 1, 3085 : 1. Okay, very good. From PC3 ping PC4, IPv4, and IPv6 address. Okay, from PC3 command prompt ping PC4 IP addresses, IPv4 10.3.85.50. Success. Ping IPv6 address 2001 db8 ACAD 3085 : 50 or : 50. Success. Configure static routing to enable end-to-end reachability. On R3, configure interface EL011 with the addresses specified in the addressing table. Okay, configure this interface on CL011 interface on R3. Go to R3, exit, interface CL011, IP address 10.133.255.255.0. IPv6 address FE80 : 3 : 1 link local. Okay, IPv6 address 2001 db8 ACAD 1013 : 3 prefix 64. 001 db8 ACAD 1013 : 3. And shut down. Okay, now the link is green, and configure the routing, the static routing on R3. Exit IP routes. The default static route on IP4, the NAT hop IP address 10.131, and IPv6 route : /0 2001 db8 ACAD 1013 : 1. Okay, and now on PC3 issue a ping to PC2. Okay, this is PC2 IPv4 and IPv6 address, and go to PC3 and ping 10 to 6050. Success. And IPv6 ping 2001 db8 ACAD 1060 : 50. Success. Okay, examine CIM and CEF details. You will examine CEF details on the devices you have configured. The objective of Cisco Express Forwarding CEF is to speed up the process of moving data from one interface to another. To do this, as much as data as possible is pre-compiled into two tables: the forwarding information base FIB and the adjacency table. These are basically shortcuts that identify what interface packet should be sent out of and how it should be framed. Issue the command show IP CEF to see compiled CEF table, which tells the device what to do with a frame or packet based on its destination address. This table gives the device a quick answer and keeps the CPU from getting directly involved. For example, packets destined to 10.2.0.0.16 network are quickly resolved to the next hop address of 10.1.13.13 exceeding interface gigabit 001. Okay, for R1, the exit interface is gigabit 001 and next hop is this 13. And the destination are the VLANs 50 and 60. So you can see here, show IP CEF Cisco Express Forwarding. This destination address uses this NetHub address and this interface, this exit interface. Try to do this on R1. Show IP CEF. Okay, IP before CEF is not running. Okay, to enable this is use configure terminal and IP CEF. Okay, exit and now show IP CEF. And now you can see this route for this destination 10.2.0.0.16 is the static route configured to reach the VLAN 50 and VLAN 60 from R1. And the NAT hop is 10.1.13.13. This is the NAT hop, and the exit interface is gigabit 001. The exit interface on R1 is gigabit 001. Very good. And you can see another static route. Show adjacency, which shows you the address neighbors on each interface. R1, show adjacency. Okay, Packet Tracer does not support this command. Okay, but you can see the following. Okay, on R1 gigabit 001, you can see the address of the neighbor. Is 10.1.13.13. On gigabit 001, you can see the neighbor, that is 10.1.13.13. 10.1.13.13. On gigabit 001, you can see the IPv6 address D1. On gigabit 001, you can see the neighbor IPv6 address D1. Serial 011 is point-to-point. This is point-to-point connection. And also for IPv6. Expand this a bit and issue the command show adjacency detail, and you will see that the router has precompiled the layer 2 headers and other details that allow it to package information quickly. Okay, show adjacency details. This command is not supported by Packet Tracer, so you can see more detail. For example, gigabit 001. The address, the IPv4 address of the neighbor on this interface is 10.1.13.13. 20 packets, 1,680 bytes. Okay, and you will see that the router has precompiled the layer 2 headers. Okay, gigabit 001 for IPv6. For serial interfaces, point-to-point. Okay, thank you very much.